mean, it's being real with ourselves on where the problems are. Okay, so the problems that the early movers have is they've got some uncertainty relative to the regulatory process and what could come up out through that. And I get all that. I'm not criticizing the regulatory process. It's just is what it is right now. But it's real and it's a known item that creates some ambiguity in the timescale and the cost. Okay, that's big and it's important for us to internalize. So if that's true, and we all believe it is, I think, then how can we backstop the early movers a bit? How can we create some window there to keep any one of the early movers from getting crushed by it? And I think that's what's being discussed right now. It's being discussed within the industry, and I think it's going to come up hopefully within some of the state and federal agencies and government bodies. But I don't think this can be solved just on the non-governmental side. I think there's a role that we can all play and the industry can play to also support and backstop it. But the early movers are going to need more support than that.
Just because the facts are A, if the narrative is B and everyone believes the narrative, then B is what matters. But it's our job in our industry to speak up proudly, soberly, and to engage people in this dialogue. Those 2.5 billion people that are in energy poverty, they need us.
America cannot meet this threat alone.
If there is a single country,
of course, the world cannot meet it without America.
that is willing to
We're going to need you, the next generation, to finish the
overhaul
job.
nuclear regulation
We need scientists to design new
and
fuels.
focus on net public
We
benefit
need engineers to invent new technologies. We
over absurd levels of radiation
need
protection,
entrepreneurs to sell those
then
technologies.
we will march towards this.
We need workers to operate assembly lines that hum with high-tech, zero-carbon
We have
components.
unlimited prosperity for all humans.
We need diplomats and businessmen and women and Peace Corps volunteers to help developing nations skip past the dirty phase of development and transition to sustainable sources of energy. In other words, we need you.
Okay, welcome to another episode of the Fire to Fission podcast, where we talk about energy-dense fuels and how they can better human lives. My name is Mark Hinaman, and today I'm joined by Craig Ranson, Executive Vice President, Installed Base America at Framatome. Craig, how you doing this morning?
I'm doing great. Thanks for having me.
Yeah. So, Craig, let's dive right in. I want to touch on your background before kind of working on Framatome or talking about Framatome. Been there a long time, since before Framatome was known as Framatome. So why don't you give us a history and talk about how you got started there?
Yeah, I'm a graduate of Virginia Tech in electrical engineering. And I had a real passion when I first came out of the university to design controls and robotics with a real focus on robotic delivery and operation of robotics remotely. And I was blessed with the opportunity to be able to do that at the time it was B&W Nuclear Services, to become Framatome a few years later. And, I jumped right in. I was designing robots and robot controls. And the cool thing about Framatome was you don't get compartmentalized. You get to design the system, and then you get to use the system in the field and take it with the team to the field to see it operate. And that kind of led me into some real learning experiences along the way, because you think you've got this thing figured out. You think you got a good system, a robust robotic delivery platform. In this case, we were designing a reactor vessel examination robotic system to do ultrasonic examinations of reactor vessels, and specifically the welds that make up the reactor vessels. And we had been working on this project for about 3 years, and we were ready. We thought we had tested this thing. It was coming together. It was an impressive looking robot. And I remember taking the robot on its maiden deployment to a nuclear power plant, and we had it in the yard out at the plant, and all the employees at the plant were coming there and taking photos of it with us. We were like celebrities. And then we had a rude awakening. We actually took the system into the harsh environment that it has to go into, like borated water, 20 feet underwater, and about 5 hours in, it starts to take on water, and part of the robotic system actually flooded a bit. We got through the job. We did the job we were committed to do. It did take longer than we were supposed to, and I did learn an awful lot about how to make a system more robust than we did at the time.
I love that story. Yeah. That's classic. That's classic engineering. You're like, this is going to be great. It's going to be flawless. And then you show up.
I was humbled very early in my career, that's for sure.
So how long did you work on that? Like 3 years that
It
they had
was
been
about a
working on
3-year
that
project.
project
Yeah.
before?
Yeah.
Yeah, before
The name of the
trying it
robotic
out.
system was called Ursula. And don't ask me what it stood for. I can't even remember.
That's fascinating. 3 years for like a 5-hour job.
It took us 5 hours to ruin the job. It took about 10 days to complete the job.
Okay, gotcha.
Yeah.
Well, and hopefully they took the robot back and iterated and improved it, right?
We've come a long way since then. We now perform them routinely for about 4 days.
Yeah, there you go.
Yep.
We call this learning, right?
That's exactly.
Okay. So sorry if I missed it. Was that at Arriva or?
It was when I was working at all the different Framatome names companies. Yeah.
Okay, formerly Framatome names.
Yeah.
Okay, so what does Framatome do? Give us kind of a big overview of the company, size of the
We're
company, primary
yeah,
business lines.
we do all things nuclear, man. We're all in for nuclear. We believe in it and what it can do for the planet, our economy, for energy independence. We perform and provide engineering products, services, fuel, I&C solutions, all to the nuclear fleet, both the existing fleet that's been in operation for some time, but also in support of advanced reactors and SMR reactors as well. I'm sure we'll talk about that.
Yeah. So supporting installed base, or that's in your title, I guess. Do you guys segment between advanced nuclear and kind of the installed larger facilities?
That was the original thought, that this organization that I'm responsible for would focus on the existing reactors and existing fleet. However, we've now taken on the responsibility of supporting both. So as the advanced reactor SMR fleet has grown and that market is frankly really started to grow, we've taken on the support of that as well. So our installed base business, so the best way to think of it is through what it's not. It's everything but fuel and I&C.
Okay. And INC, instrumentation and
I'm
controls.
sorry, instrumentation and control.
Yeah. Okay. Craig, I mean, you've been there a long time. How have you seen the industry change over the past 5-10 years?
Let's
Or
just
even
continue. Yeah, it's a great question because it's really continued to improve over the years, the performance of the nuclear fleet. I think it's one of the things we ought to be the most proud of is how
capacity
far the
factors.
nuclear industry has come in terms of its efficiency, its capacity factor, the cost to produce electricity. I mean, it's really improved over the last 20, 25 years. And everybody's been a part of it. Suppliers, the utility operators, the industry institutes like INPO, NRC, everybody's played a role in ensuring that this fleet is driven towards excellence. And I tell you, they've been on a good track.
Yeah. So all things nuclear, I mean, that's a pretty large catalog of products for folks that may not be able to conceptualize it or have experience. But can you just give a couple examples? I mean, you got this robot that's doing inspections
So I'll give you a
in fuel
spectrum of
facilities.
it. We do things from cybersecurity for nuclear to isotope production for nuclear, and we're pretty proud of that. We service the existing reactor fleet. We help provide technology bricks to the advanced reactor and SMR fleet. We provide fuel. We provide I&C, instrument control solutions. So it's a lot. We replace large components in nuclear power plants. These plants have been operating for a while, and some of these big components eventually need to be replaced, like steam generators or pressurizers or reactor vessel closure heads. And we're pretty good at that. And we do the big stuff and the small stuff when it comes to nuclear.
Yeah. I think you posted about that on LinkedIn recently, or how you guys had pressurizer repair.
We did, yeah.
That was pretty cool. Can we talk about that?
I can, yes. We have a very talented and strong component repair and replacement organization as part of our team. And they are pretty good at quickly being able to mobilize a solution, whether it be difficult or not, to be able to address a component failure or something that needs repairing inside a nuclear power plant. And we're basically the go-to folks when people have that kind of problem. But in this case, as you can tell, it was so critical that we get there quickly that we mobilized 55 people on a chartered 737. It got there as fast as possible, efficiently as possible, to get that plant safely back online.
That's incredible. How big is the organization? How many people work at Framatome?
We've got over 2,000 in North America. For the installed base business that I'm responsible for, it's a little over 1,000. And we're growing substantially every year here now. So to ramp up it to meet the demand, we decided to jump in. We decided to say, look, we can sit on the sidelines and wait to see it happen, see if this is really going to happen or not. Or we can take a bet and just jump in and say, you know what, if we're going to be early movers we're going to help these early movers and be on the forefront of this. We've got to move now. And so we started to make investments a year or two ago, and we've got a hiring plan and a hiring trajectory that's quite remarkable. We're looking to bring in over 450 people over the next few years.
Yeah, and not like in a couple months or in a year. It's happening now. I mean, I was
Right
cruising
now,
your guys' website before this, and you got a ton of jobs listed.
we do. And we've got a whole nother ton of jobs ready in the wing as soon as we get these started to be filled. So,
Yeah.
and the good news is, Mark, the interest in nuclear is tremendous right now. We had folks at a lot of these career fairs at the different universities that we go and attend, Virginia Tech and NC State, Penn State, the general large area of schools that we pull from. And it was night and day different in terms of how much we were getting the attention of the student body. There were other companies that were jealous of the Framatomes because there's just a big interest in nuclear right now. I'm telling you, it was the most attendance we've had in recent years with regards to folks wanting to know about how to get in the nuclear industry and showing interest in jobs in the industry. It's promising, it really is.
That's really exciting. I feel like the trend over the past decade has been a move away from hardware and away from hard physical solutions. And as the climate change movement has progressed, there's been kind of a shift in that.
It has.
Are you seeing some better talent being engaged in the industry? Not just perhaps numbers, but quality of applicants and quality of people that want to come in?
Well, it's been a while since the industry has injected itself with a bunch of new talent. Okay.
Yeah.
So just bringing new talent is remarkable in itself because they're a new set of eyes. They bring new technologies with them. They bring new tools that they learned at the universities into these old programs that were slow moving. And now it's kind of shaking everything up a bit. So let me give you just a simple example. One of the things that we do is we help defuel the reactor. We take the reactor apart, defuel the reactor, and then once everything's done, we refuel the reactor with the new fuel to go back in. Okay? To do those activities, there were these long-handled tools that were developed about 35, 40 years ago. They were frankly cumbersome, complicated, and they broke down a lot. Okay? Everybody lived with them. Okay, for the last 30 some years, everybody lived with them. Well, guess what? We hired a few early career engineers and deployed them on a couple of jobs to get them some experience in the field and what it's like to be working at a nuclear power plant. We put them on these crews. And they came back and said, hey, why are we using these funky old tools, man? And we didn't have a good answer. We said, well, hey, here's a couple of grand of R&D. Why don't you see what you come up with? They developed over a period of 6 months a whole new set of tools. The whole fleet almost has replaced their toolkit with these new tools. Now we're going international with it. Just because they just asked the question,
I've seen that time and again in my career. I think that's a benefit of kind of rotating people throughout organizations and giving people a chance to try different things and learn and see different things. Like a fresh set of eyes is so useful.
Absolutely.
So, Craig, what companies might be considered competitors? If somebody's trying to get a feel for your organization, who in the space might do some of the same things that you do?
I think maybe Westinghouse comes to mind. I mean, they're a big, well-known competitor, and they have a strong organization as well. Competition has really helped bring this industry to the next level, to be honest. So it drives all of us to innovate, to constantly improve and keep our costs down and look for better ways to service these plants and to keep these plants running. The other thing I think I'd say about the concept of competition, certainly the competition is strong, okay, and it's vicious as it should be in a capitalistic market. But I will say, given the market conditions and the situation that's blossoming, if you will, in this industry right now, there's a lot of times you find that you're competing in one segment and you're partnering in another segment. to the betterment of the
Yeah.
customer. And we're seeing that more and more today than we have in the past. But when you compete hard and when you're partnering, you truly partner.
Yeah. I've seen that a lot, specifically with people that may not have a capital budget to solve all the problems themselves, and having a consortium or collaboration to work towards a solution can be really useful in industry. It's a fine line to walk because, like you say, you got to figure out when to collaborate and when to compete.
I think for us, it's easier because you can separate segments of the market. In one whole segment of the market, you could truly be in a competitive state. But over here, maybe in advanced reactor space, you could do something different.
What all segments exist? I'm cruising through your website, and you've got advanced nuclear. You talked about it. Design and engineering, component manufacturing. Let's see,
Yeah.
cybersecurity.
Yeah, services. We do a lot of services at plants. We do a lot of inspections. I'm talking about robotic inspections of the primary components of the plant that take a lot of robotics. And that's kind of where I grew up from. I mentioned it earlier in the podcast. But we also do a lot of component repair and replacement. And we do a lot of engineering, special engineering services. We may do a specific analysis to help with a new component going in, or let's say an updated reactor coolant pump design or a seal solution. There's always these opportunities to support uprates and increase the capacity of the plant to service its rate base better.
I'm curious on that. I like that idea, and I know that the industry has been optimizing this solution for a long time, especially over the course of your career. But we're pretty close to being optimized at existing plants, right? I mean, the 90+% capacity factors. I see you being like, no, we can get better. We can always do better.
I still think we got room to improve. I'm excited about it still, primarily because there's two reasons, Mark. One, technology continues to advance. Let's think about it. Machine learning and AI is just now being applied in nuclear. What can that take us to? It's already being used now in the very beginning stages for predictive analyses. Okay, let's say predicting when baffle deformer bolts may degrade and fail over time, or predicting when a steam generator tube may have wear conditions that would need to be serviced or replaced. That's just one example, but the other piece that's feeding into it is we went for a long time without having an end game on how long we were going to run the plants. I mean, it was getting uncertain there for about 10 to 15 years. And so when you're an accountant or you're trying to run your company at a utility, how much do you invest in a plant? You know, how much can you sell your business case if you don't know what your payback period is? Well, guess what? With the IRA, that's changed the game. Now we have a payback period. Now we know how long these plants are going to intend to operate. Now you can create sound business cases for them. And that means you can invest in the plants to do the uprates, to do improvements, to improve the capacity factor even farther. I'll use an example in terms of technology space that is just quite remarkable. A lot of plants still had alloy 600 weld metal in their welds. And it's known to be a reliability problem if it's not mitigated. It eventually will have problems over time because of the caustic nature of the materials it's in contact with. And so we developed just recently a solution called cavitation peening. And what it does, it creates vapor bubbles at a high pressure that hits the surface. When you deliver it, it looks like you're just putting like a pressure washer on the surface of the weld metal. It's what it looks like. But in reality, it's such high energy vapor bubbles that it actually dimples the surface of the weld. You can literally feel it and see it. And what it does, it takes the tensile stress away on the surface and puts the surface into compression. Well, that eliminates the possibility for any type of degradation or cracking. And so we're just now applying that to the fleet. That's a new technology. And that's going to greatly improve the reliability of these plants that still have alloy 600 weld metal in some other locations. Now, can we get better? Yeah, I think we can get better. We're doing it right now.
That's a phenomenal example. I love that. It's just nerdy enough, the mechanical.
I'm sorry for the nerdiness, but I am an engineer. I warned you up front.
I know, it's great. That's the problem on podcasts like this. You get two engineers talking, and I worry sometimes that people haven't seen these things, right? So you got to kind of paint a picture, but I think you did a good job. Like, you've got this physical weld, and then you're blasting it with bubbles, just like
Blasting
you
like a
said, that
pressure
are kind of
washer.
exploding, and it's changing the shape of the metal,
It
and then
is.
that changes the physical lattice, the characteristics of the metal, and how it performs and behaves.
It's counterintuitive. Just think bubbles are going to dimple one of the hardest metals known to man.
How did you guys figure out that solution would work? I'm just thinking about your
Well,
process, and as an
it was a
organization, you
classic
talk about this
example.
R&D.
Yeah, I'm sorry. It was a classic example of looking at what's been done and outside of nuclear and saying, you know what, that could be applied inside nuclear. We can modify it, make it better, dial it in. Obviously, we got to have all the special processes qualified and all that stuff. We do that. But the fundamental concept is let's figure out what's going on in the world, take the best of it, and let's take it to nuclear and make it even better. And that's what we're doing. Another
I
example of
love that.
that is these power plants have buried piping everywhere in them, underneath tanks, underneath buildings, underneath roads. There's all kind of piping used to move liquids around the plant, water or other types of liquids. And these plants are now getting in their 40s, 30s, 40s, 50 years old, right? And so there's an issue with needing to service these piping to make the plants more reliable.
Yeah.
Well, we found a solution outside of nuclear that's being used to actually spray on a new pipe from the ID. Now, imagine that. You actually create a new pipe from the ID without having to dig anything up with a little robot. All you
Yeah.
need the old pipe for, Mark, is a form. So now we've got a safety and a non-safety solution for replacing all the piping without being intrusive or costing a lot of money to the utility. That's how we're continuing to make these plants better.
I love it. Does it just create like an internal coating, or does it expand
Oh,
the
it's more
pipe?
than a coating. It actually creates a thickness of a pipe. So
Yeah.
it's structural. In other words, so from an
Okay.
engineering perspective, you size the thickness that you need to maintain the structural integrity of the new pipe because the old pipe's
Yeah.
not even needed after you get it on.
And achieves a comparable ANSI pressure rating
That's
that
correct. All
is sufficient.
qualified.
Yeah. Yeah. That's awesome. Okay. Well, Craig, that was some of the tidbits and nerdy details that I wanted to get out of you. So thanks for entertaining me. Let's zoom out a little bit to kind of the broader energy industry. What are some of the biggest hurdles that you see
Well,
the U.S. facing in order for us to
number,
build more nuclear here?
yeah, thank you. That's a great question. I mean, number one is we need to support the early movers to get across the line and get moving. Okay. Everybody is waiting and watching. There's a whole industry ready to move, but it takes two or three early movers to get this thing going. And that is the most pressing item today. The infrastructure is building up behind it. People like Framatome, or companies like Framatome, are taking the leap of faith and investing. The SMR and AR providers are taking the leap of faith and investing. But we need two or three early movers to be bold and do this. And we need both government, federal and state, and industry support to back them. That's the key thing right now. Now, right behind it is those things that we talked about, making sure you're moving now to hire the people and to bring in those early careers in particular. That is going to be the future for the industry is early careers. You're not going to bring a bunch of mid careers from some other industry into nuclear and solve a problem that the competition's too strong for. You need to build your own. That's secondary. That's really right behind the early mover problem. Right alongside that is making the needed investment for facilities and technology to support it.
Yeah.
To me, those are the most important things.
So how do you think we do that? Because I've talked to utility executives that everyone wants to be second, or maybe not even second. They want to be fifth or 10th to beat of the game to go and build a new plant. How do we get people comfortable to make some of these big investments?
Well, I think in the end, it's black and white, really. I mean, it's being real with ourselves on where the problems are. The problems that the early movers have is they've got some uncertainty relative to the regulatory process. and what could come up out through that. And I get all that. I'm not criticizing the regulatory process. It's just is what it is right now. But it's real, and it's a known item that creates some ambiguity in the timescale and the cost. Okay, that's big, and it's important for us to internalize. So if that's true, and we all believe it is, I think, then how can we backstop the early movers a bit? How can we create some window there to keep any one of the early movers from getting crushed by it? And I think that's what's being discussed right now. It's being discussed within the industry, and I think it's going to come up hopefully within some of the state and federal agencies and government bodies.
Yeah.
Because I don't think this can be solved just on the non-governmental side. I think there's a role that we can all play and the industry can play to also support and backstop it. But the early movers are going to need more support than that.
So financial support from government.
Yeah, some guarantees around cost sharing above a certain value, to a limit, of course. We don't want to leave things uncapped, but to support primarily financially, especially around the risk side of it, where it can cost a lot on the first two or three.
Yeah.
Until we get the bumps in the road worked out, if you will.
It feels like this is an opportunity for, just like we were talking about earlier, the collaboration piece, where you can have a consortium of folks, or maybe even a fleet order, right? Where not everyone's going to be first, but if you want to be fifth, then you got to put in 20% of the cost now to have a deposit, if you will, that then eventually you'll get the fifth plan and have some learnings, but pay to play up front a little bit.
You're exactly right. That's how the commercial fleet can support as well.
Yeah.
And we're seeing some of that. I think there's some consortiums being discussed and formed where you have two or three utilities saying, you know what, we're going to pick a design and we're going to go at this together to share the risk together. And that'll help. But I still don't think that alone will get us there.
Gotcha.
But Mark,
so,
once the first two or three go through, it's going to be a fun ride.
Yeah. Well, there's just so much upside in the industry, right? I mean,
Yeah.
I'm excited about it. So you mentioned not bringing people from other industries. I want to push back on this idea a little bit. I talk to people from solar, from oil and gas, from other sectors of the energy industry. And every time I talk to them, everyone loves nuclear. They're all stoked
Great.
about
That would be a pleasant turn of events. I agree. There's an interest in nuclear. I just don't want the industry to think that we can solve the large scale hiring that's needed solely from grabbing mid-careers, if you will, from other industry, because frankly, it's a more competitive environment. I mean, so does everybody else want a lot of these mid-careers. And we're bringing some in from outside of the nuclear industry. It's happening. You're right. But I'm not yet seeing it at a scale that's going to solve the problem alone.
Yeah. Okay, so you have a lot of posts on LinkedIn periodically advocating for the industry. How can we do this to help? I mean, you mentioned kind of the regulator problem, and I think that's only going to get solved if it's an act of Congress, which means that we got to have conversations like this and get people aware and advocate for the industry. Do you think it's helpful for the industry? And if so, how can it be more helpful, or how can we get utility executives to do the same?
Well, I do think it's helpful. I think we need to toot our own horn a bit. There's a lot of great work that's just happening quietly behind the scenes. It needs to be visible a little bit more. And that's part of why I make some of the posts that I make is I see some of this great work and innovation and technology being applied and people coming together and rallying behind a cause. And I want to share that. And I'd love to see more of my colleagues in the industry do it. Some are really strong communicators out there that are sharing similar types of message, but some are awful quiet. And you know what, Mark, I'm going to add that to my list of things to talk to them about when I meet with a lot of them in just my course of doing business. And I'm going to add that to the list. I'd like to get between the ears as well.
How does a utility executive think about this idea of they have a portfolio of technologies to choose from and they can't necessarily pick a winner or a favorite, even if they might recognize some of the benefits of nuclear? I mean, is it just talking factually about it? Help me think about that? Because I've seen that a lot with utility executives. They're like, well, yeah, nuclear is a part of our portfolio, but we can't cheer it on and pick it as a favorite child. We got to love all of our children equally.
Well, I don't know that I disagree with the concept. I think is in particular with clean energy sources, nuclear being one of them. I think there is a bit of a harmony that can play out in the future state. I think nuclear needs to have a more prominent role, and that's happening. I think a lot of it also comes down to the financials, and we need to recognize those financials. There's no free lunch here. We all got to earn our keep, and nuclear is no different. But you know what? I'm game for that challenge, right? I mean, I think we can hold our own.
Well, as a service and technology provider, people that build stuff have a growth mindset that is phenomenal. I just absolutely love it because it's a sense of ownership in the world that you can transform the world around you and actually modify how expensive things are, how effectively things get done. And yeah, that's exactly what you guys do for your business, right?
Yeah, I can tell you that it's definitely our mindset. We see the potential and we go for the potential. You know.
So, Craig, you talked a little bit about advanced nuclear. I've got this question here: microreactors, SMRs, large modular reactors, or all of the above?
All of the above. Love it. I think each one has a role to play. Each of the main suppliers have a role to play. Mark, we had a choice to make a few years ago. Do we, in the U.S., do we develop our own technology and be a prime, let's say, another OEM in the mix? We had the full capability to do that in North America. We could have. We decided instead to be a technology provider for all of them, to be an accelerant, if you will, to help them all be successful as best we can. We didn't pick winners and losers. Let's let the market pick that. If there's going to be winners and losers, let's let the market do it. And we'll be right there with them.
Yeah.
And
it's a different business model
for us. Yeah.
Yeah. As the advanced reactor space grows, I think that's really intelligent that you guys chose that approach, because then you can service all of them. You're not directly competing, and you can perhaps share learnings from one to another.
Agreed.
Not to pick winners or losers, but is there a certain technology that you're more excited about, or something that with advanced reactors that gets you jazzed up and you're like, oh man, I want to see a molten salt reactor built?
I find each one of them really exciting in their own way. I really do. I mean, I'm not.
I like that. That's diplomatic answer. There you go.
I'm not really trying to sidestep the question. I really do think each one brings a very unique set of solutions to the table with a specific offering. I like the portfolio that people have to choose from right now. I think each one plays a role. I was actually at a dinner with an industry executive, and I posed that question to the executive. And he goes, really, I think they all have a good role to play. And this has come from somebody that's got to pick somebody at some point.
Well, that's great. That's exciting for America and the world, in my opinion. So, we talked a little bit about how the nuclear fleet has changed. Capacity factors have increased. The technology is getting better. There's improvements that are being made every day. You talked a little bit about how Framatome's engaged in that. With the new reactors coming online, there's only more opportunity to do that, right? It's new technology.
Oh, yeah.
Framatome's going to be involved in that.
Well, what I'm seeing now, Mark, is there's learning going back and forth between the technology being developed for the new reactors and the old reactors and vice versa. So now we're seeing concepts being formulated and tested and brought to fruition for the SMR-AR market that also has some retro application back to the existing fleet. So there's this whole new learning that's going on now that just wasn't there before.
Yeah, that was really interesting to me when I first started researching getting into the space. I was like, well, how many different types of reactors do we use in the US? Surely it's at least a dozen. And it was two, right? Light water reactors or pressurized and boiling water reactors. And I think with the expansion of different types and how we're going to see some of these come to market will be really exciting.
Well, if you think about it in terms of even, let's say, other capabilities like isotope production, okay? Some of these reactors are more conducive to supporting isotope production than others. For example, we're producing large quantities, a large portion of the world demand for lutetium-177 that fights prostate cancer. And that's being produced in a CANDU reactor which is very conducive of being able to generate isotopes at scale 724, 365. And you don't have to wait for a refueling outage to do that in a CANDU reactor.
Yeah. That's great. So, Craig, what motivates you at this point in your career?
I tell you, I've really grown to appreciate what nuclear can do for the planet, for the people, for our economy, for energy independence. It just has a number of really good attributes that, frankly, I really want to see be taken to the next level. I'm excited in this back half of my career to be able to be a part of it now and see this renewal of focus on nuclear being a part of the clean energy portfolio. And I'd like to see that through. I've got handful of more years left in me, and I think it's going to be an exciting run.
Yeah. So what do you think is the most impactful step that most people can take to help us build more nuclear? We talked a little bit about supporting early movers in the industry, but what about listeners, people that aren't potentially directly involved in the industry but are advocates?
I still think first and foremost, write your congressman, advocate for support for the early movers. It's game changing, not just for this industry, but frankly, for our whole economy. It's a big deal. What else can we do day to day? I'd encourage folks to engage in STEM in the high school level, the middle school level, and really promoting STEM type programs and initiatives. Get people visible to what can be done in this space, because we're going to need some really talented engineers, technicians, welders, electricians to make this all happen. And that's something we all can do.
That's great. I love that piece of advice. I give my niece a STEM kit almost for every one of her birthdays. I support that methodology.
It's great. In small ways, we all can do a little bit. It's impactful.
Craig, where can people find more information about you or Framatome and anything else that you'd like to promote for the organization?
Yeah, Framatome.com. It's pretty simple. We've got a great webpage up there, and I encourage folks to go take a look at us. I will make a shameless plug for this recruiting that we're doing. I told you earlier that we're going to hire at least 450 talented individuals, and we're hiring today. We'll be hiring tomorrow. We're all in on this, and we're making investments in our facilities and our people. It's just a fun journey we're on, and if you're interested in nuclear and having a career where you get to spend a little bit of time designing and developing solutions, but also spending time at a power plant, really getting your hands on it, come to Framatome. That's how I started my career.
It's not shameless plug. It's a big benefit of doing the podcast, right? That's great. It's always great when you can be like, hey, we got jobs. You on a job? Okay. So Craig, last question. Leave us with your most positive vision of the future. What's the world going to look like in 10 to 20 years?
If I look out in the future, I really see this nuclear industry providing more than just electricity to the grid, right? It's changing the clean energy economy that we have, producing hydrogen that's supporting clean energy downstream solutions, that it's standing up and supporting large manufacturing and chemical plants through a clean energy solution of delivering, let's say, high temperature steam to these locations. It's producing electricity, obviously, not just for the grid, but for cars and trucks and all things that use electricity in a clean energy way. And it's doing it 7/24, 365. Is it the only clean energy solution? Absolutely not. We're blessed to have other ones too, and we need all of them working together to meet the growth demands that we're seeing in this market. But I see that as what this looks like 10, 15 years.
That's great. That's a great place to leave it. Craig Ranson, thanks so much.
Thank you, Mark.